number 5A1, 2 and B2 and B1. Okay, for the 5A1, we must read the question properly. A 100 cm rod A expand by 8 mm when heated from 0 to 100 degrees Celsius. Calculate the coefficient of linear expansion of for rod A. So we have for the first thing we must to put out the information at the question. Okay, so uh, we can get for the length knot we have 1 meter, length we have 1.008 meter, T knot we have 0 degree Celsius, and T we have 100 Celsius, and we want to find the alpha, who is the coefficient of linear expansion of A. So we can use this equation, and we substitute the value in the equation. So we can get the alpha is 8 times 10 power of 95 per degree Celsius. Thank you. For the 5A2, we have an aluminum rod is 60 cm long at 20 degrees Celsius. What is the length at the temperature of 100 degrees Celsius? So at this question, we have the temperature and the temperature knot. So we must first of all we must to put out the information in the question. So in this question, we have the convert the 60 cm to the meter, so we can get 0.6 meter. T naught we have 20 degrees Celsius, T we have 100 Celsius, and we want the length at the temperature of 100 degrees Celsius. So at the question we have the alpha, the coefficient of linear expansion for aluminum, which is 24 times 10 negative 6. So at the same we use the same formula, which the length knot times alpha, the change of temperature plus 1. So the we have the temperature. We must to calculate the temperature, which is the T minus T naught. So I calculate that, and we can get the length is 0.6012 meter. When a metal rod A of length 100 cm and is heated from 0 to 100 degrees Celsius, from that we can get the change of temperature. It expand by 0.08 cm, and another metal rod B of the same length, which is as 100 meter length, heated through the same range of temperature. So we can get the change of temperature is 100, as expand by 0.035. I think it's the length. So we can get the length knot is 100 centimeter for the both rod, which is rod A and rod B for the length knot, and for B1, they want to calculate the coefficient of linear expansion for metal A and B. So we want to find the alpha of metal A and alpha for metal B. So in this question, we must, for first of all, we must to put out all the information that we can get. So we can get for the both rod, the L naught is same, which is 1 meter. For the, and we say the range of temperature is same, so we can get the 100 degrees Celsius for the change of temperature for the both from the both from the both from the both road. Okay, so we must to convert the unit of the length in the question, which is we can get the length for A is 1.0008 meter, and length for B we can get a 1.00035 meter. So at this time we must use the same formula as a 5A, so we can uh, put in the value in the formula, so we can get the from the for the alpha A we can get a 8 times 10 power of 96 per degree Celsius, and from the alpha B we can get a 3.5 times 10 power of negative 6 per degree Celsius. Therefore, the 5B2, we must read the question. These two insulated metal rods A and B are joined together with 100 cm length and have a same cross-sectional area. It heated from 0 to 100 degrees Celsius. If it expands by 0.07 cm, determine the initial length of metal A and B. So in this question, we want the length knot of A and length knot of B. So for the first, we must to take out the all the information in the question. So we know the total of the length knot of A and length of B is 100 cm by the listed in the question. So we must know that question firstly, and they give the exchange of length is 0.07 centimeter. Uh, and if we convert to meter, we can get 0.07 times 10 over times 10 power of negative 2 meter. So the T naught is 0 degrees Celsius, and the T is 100 degrees Celsius. So in the for the first we have the alpha A and alpha B. We get in B1 question B1, which is alpha is 8 times 10 power of negative 6, and alpha B is 3.5 times 10 power of negative 6. So we must know this question for the first to convert it to in the equation. So length knot A, we move the length knot B on the right side, so we can get the 100 cm minus length knot B. So we change the unit of the 100 cm, so we can get 1 meter minus length knot B. So in this question, we want the we want the formula. We will add it. We will sum it by the change of length A plus the change of length B. So they are two formula combined in this question. So we will get in this equation. So we can take out the change of temperature, move to in front because the value is same for the both side. So we will put the length knot A in this question by 1 over length B. So we can get the length knot B first. So we put the value of the uh, put all the value at the question in this equation. So at last we get length B equal to 0.222 meter. For this length knot B. So we put it on the value of length knot B in the equation that we move it at the above. So this is the equation length knot 1 equal to 1 minus length knot B. So we put the value of length knot B 0.22 meter and minus 1 minus 0.22 meter. So we will get the length of A is 0.778 meter. Thank you.
Okey, untuk soalan 6A, soalan minta dekat temperature berapa breast ring dia boleh expand supaya silinder radius 18 cm tu boleh muat dalam dia. So dalam soalan dah kasih apa tu radius of cylinder 18 cm, radius breast ring 17.9 dengan temperature 20 degree Celsius dengan coefficient of area expansion of breast 4/10 kuasa negatif 5. So first kita guna formula delta L sama dengan alpha L0 delta T. So lepas tu kita derive akan dapat L baru sama dengan L0 dalam bracket alpha delta T plus 1. Lepas tu kita masukkan nilai tadi. L sama dengan 18/10 kuasa negatif 2. L0 kita 17.9/10 kuasa negatif 2. Untuk alpha kita, sebabkan dia dah bagi beta, so kita masukkan dalam, so beta sama dengan 2 alpha. So kita derive, kita pindahkan dia supaya dapat alpha kita 2/10 kuasa negatif 5. So kita masukkan balik sini. So darab dengan delta T plus 1. So bila kita kira, kita akan dapat delta T kita sama dengan 29.33 degree Celsius. Delta T pula dia sama dengan T minus T0. So T0 kita ialah 20 degree Celsius. Delta T kita 79.33 degree Celsius. So kita masukkan je. Lepas tu ni pindah akan jadi tambah dengan ni. So T baru kita akan dapat 299.33 degree Celsius. Okey, untuk soalan 6B dia lebih kurang macam 6A. So kita direct je. So kita guna formula delta A sama dengan beta A0 delta T. Lepas tu kita derive akan dapat new area sama dengan A0 dalam bracket beta delta T plus 1. So kita masuk daripada soalan B tu, kita boleh masukkan A sama dengan 2/10 kuasa negatif 4 dalam bracket beta. Tapi kita tak tahu beta sebab dia kasih alpha je. So kita guna ni, kita buat gini. Beta sama dengan 2 alpha. 2 darab dengan 1.7/10 kuasa negatif 5 akan dapat alpha kita, akan dapat beta kita salah tulis, sorry, 3.4/10 kuasa negatif 5. So kita masukkan 3.4/10 kuasa negatif 5 dalam bracket delta T kita 30 tolak 150 tambah 1. So kita akan dapat area baru kita 1.992/10 kuasa negatif 4. Itu je.
Assalamualaikum dan selamat sejahtera. Saya akan terangkan bagaimana untuk selesaikan soalan tutorial topik 12 question 7. Jadi soalan pertama tanya, a 60 liter steel tank is full of petrol at a temperature of 30 degrees Celsius. If the tank's lid is not tight, how much petrol will spill out at 40 degrees Celsius? Kita dah tahu initial temperature, final temperature and volume of steel tank. Now volume of petrol dia dah kata is full, is the steel tank is full of petrol. Jadi volume of steel tank sama dengan volume of petrol, dan kita kena cari dia punya volume in centimeter cubic, in meter cubic. Jadi 1 liter sama dengan 1000 centimeter cubic. So 60 liters sama dengan 60,000 centimeter cubic. Itu berada pada meter, dan kita dapat 0.06 meter cubic. Kita dah tahu initial temperature and final temperature. Jadi kita kena cari change in temperature, iaitu 10 darjah Celsius. Soalan ni dah bagi dah linear expansion of steel, tapi kita kena cari dia dalam bentuk volume expansion of steel. Jadi kalau nak cari volume expansion of steel, volume expansion adalah 3 kali ganda daripada linear expansion. Jadi daripada expression ini, kita boleh substitutekan alpha dengan nilai linear expansion of steel, dan kita akan dapat nilai dia iaitu 3.6 times 10 power by negative 5 degree Celsius -1. Jadi daripada graf ini kita dapat tahu kita sedang cari volume of spill out yang daripada luar tank dan bukan yang daripada kat dalam ini. Jadi volume spilled is equivalent to change in volume of petrol minus volume of change in volume of steel. Tapi kita kena cari dulu kedua-dua subjek tersebut, dan change in volume of petrol sama dengan gamma of petrol times change original volume of petrol times change in temperature. Kita substitutekan nilai-nilai tersebut dengan yang belah kiri ini, dan kita akan dapat nilai dia iaitu 5.7 times 10 powered by -4 meter cubic. Dan kita akan lakukan bersama juga pada change in volume of steel, dan kita akan dapat nilai 7.16 times 10 powered by -4 meter cubic. Dan kita akan gantikan nilai change in volume petrol, change in volume steel dengan nilai-nilai tersebut, dan kita akan dapat jawapan dia iaitu 5.484 times 10 powered by -4 meter cubic or 548.4 cm cubic. Itu jawapan dia. Kemudian soalan seterusnya tanya, a copper radiator of capacity 15 liters is filled with coolant at 30 degrees Celsius. Jadi, when the engine is running, the temperature of the radiator rises to 96 degrees and the coolant overflows. Now, sub-question dia tanya, explain why the coolant overflows. Jadi jawapannya adalah the coolant overflows because the coefficient of volume expansion for the coolant is larger than the copper radiator's coefficient. Tapi kita tak tahu volume expansion bagi coolant sebab dia hanya bagi linear expansion. Jadi kita kena buat benda sama seperti ini, iaitu gamma sama dengan 3 alpha, dan kita akan dapat nilai. Jadi walaupun kita convert, nilai dia tetap lebih rendah daripada volume expansion of coolant. Jadi pada soalan sub-question kedua, calculate the amount of coolant spilled out in centimeter cubic. Now dia dah kata copper radiator is filled with coolant. Volume kedua-dua ini adalah sama, 15 liters, dan kita tukarkan pada centimeter cubic, dan kita dapat 15 times 10 powered by 3 centimeter cubic. Initial temperature dia dah bagi, final temperature dia dah bagi, dan kita dapat change in temperature iaitu 66 degrees Celsius. Nah, benda sama tadi, kita kena cari volume expansion of copper. Jadi kita akan dapat yang ni 5.1 times 10 -5 degrees Celsius -1. Dan kita akan lakukan bersama, kita cari change in volume of coolant and change in copper, dan kita akan dapat nilai kedua-dua volume tersebut, dan kita akan substitutekan dia, dan kita akan dapat jawapan dia iaitu 345.51 cm3. Selesai.